Hello and welcome to what is essentially a bit of a follow-up on the video of the Howard FM converter tuning. And in that video we used this sweep generator right here, and I had tossed up some pictures of this one and this one, and I thought it might be a good idea to follow that video up with a demonstration of this unit as well as the one that's over here, just to go over some of the differences and show you how they operate and let you make a decision as to which one you might want to shop around for. These are very common. I see a lot of these out there. I have seen a few of these. This one appears to be fairly rare. I have only seen this one, and I was lucky to be able to grab a hold of it. These are the E410 series. These are just both labeled E410. I don't think, yeah, there's no C or A or anything on there. Or excuse me, E400 series. There's a saying, be sure brain is engaged before putting mouth into gear. At any rate, I'm climbing up here on the camera a little bit too, hoping that some of the echo will go away by doing this. I'm afraid being this close to it though, I'm going to make a lot of aqualung sounds, and you'll hear my lips going all the time. I have to hang up some soundproofing in this room to get rid of the echo. Either that or move this whole lab downstairs, which is my my long-term plan, but I have to put a wooden floor in the part of the room, or the part of the basement down there that I plan on moving this to. Anyway, we're getting off subject. Where the heck was I? Oh yes, model numbers. These are E400 series. Says series E400, as does the one that's over here. This is the E410 series, which is a considerable upgrade actually over these two units. These two units had these microphone connectors that you see here for the marker crystal and horizontal sweep output. Both of them had the same thing on the front of the unit. One was there, one was here, which I quickly replaced with BNC connectors to interface with my cabling. That's a very simple job to do, because if you look at this photograph, you can see the thread on the BNC bulkhead connector is basically the same diameter as the one that's on that Amphenol microphone connector, and those things are horrible. They're always coming loose and giving you trouble. I could not, however, change this connector over, because you can see from the diameter of the thread on that style of connector, the BNC connector would literally, or bulkhead, BNC bulkhead connector would literally fall through the hole. There's nothing, no way to attach it. Now you could put a couple of big fender washers or something in there, or if I had access to a lathe I could make up an adapter, but it's not worth the effort, because these Amphenol connectors of this style with the center pin are fairly reliable. They work fairly well. They have a spring-loaded center contact in the female portion, and they are fairly reliable. And as you can see from this cable here, all of my ends are terminated in BNC, so I can plug in my adapters. So this cable actually stays connected to the unit all the time. Doesn't present much of a problem. And quickly looking at this photograph, you can see these come in various flavors. They all use the same threaded ring, but they have different internals depending on what they're used for. You have the microphone connector. I believe the bi-pin unit is also a microphone connector. And the single pin connector is listed as an RF connector. If your unit does not have the cable with it when you get it, you can get those the cable end of that connector fairly easily. They are available on eBay from various vendors. It's an Amphenol 80MC1M. That's 80 Michael Charlie 1 Michael. Actually, I just put it here on the screen. That's a whole lot easier. This unit did away with those style connector, or the Amphenol one, or the, excuse me, the single pin Amphenol one. That one had, oh, I think this may have even had BNCs on it. I don't remember now whether or not I had to modify that. Where's the picture? No, I'm lying. It had all of the old microphone style ones in the front of it. I just looked at the photograph on the manual, so I had converted this one all over to BNC as well because the whole size is the same. It's a very simple changeover. Another major difference between the 410 series and the 400 series, the 410 series has the marker added circuitry internally. That way you have less distortion from the marker interfering with the RF signal, because the marker is actually added after the RF comes out of the unit, goes into your IF, goes back into the scope vertical input, and then the marker is added at that point, so you don't get distortion in the IF chain from the marker being injected with the RF. That's a fairly nice upgrade, actually, now that I'm taking a second look at these units. Another big difference is the way the sweep is generated. In this unit here, as well as this unit here, there's a device inside that looks very much like the frame of a speaker, and mounted where the cone would be is a metal disc, aluminum metal disc, that moves in and out inside of a coil and changes the capacitance and the inductance, reactance of that of the oscillator. And that's where you get your sweep from, and that's just connected to a transformer that provides a 60 hertz AC sine wave, and there's a control for sweep width here that changes how much voltage is supplied or current is supplied to that voice coil. Now, I had somebody send me a note last time I described that, and they said, "Whoa, that's a wobulator." And I don't think so. I think that is a brand name like Kleenex is facial tissue. Somebody's been watching Mr. Carlson, because Mr. Carlson had demonstrated his wobulator unit, which is basically a different version or a different manufacturer's version of this. His may even have been mechanically driven, like with a motor. I don't remember. I have seen motor-driven units. Kind of wacky. At any rate, these use the voice coil unit, and it is called an EMR, or electromechanical reactance modulator. That's the precision apparatus name for it. Instead of using the electromechanical sweep system, this one uses a reactance transformer, a specially wound RF transformer that has a primary that is fed the 60 hertz from a transformer tap, with a pot to adjust how much voltage or how much current the primary of the transformer is seeing, and that affects the width of the sweep. And they call that one, and let me get this right, increductor. And that's how this one is done. So this one's a lot more stable and a lot less susceptible to shock, because it's not relying on a mechanical voice coil type of arrangement to perform the sweep function. It's all done electronically within the transformer. So they're doing it completely electronically in this unit. Also, this unit has fixed blanking. The sweep in one direction operates the oscillator, changes its resonance. On the way back, there's a diode that cuts off the reverse part of the sweep, so the modulator is not modulated on the return. This one also can turn off the return, turn off the oscillator on the return. It has a blanking switch. This unit over here does not. This produces a trace both forward and backward, which is kind of annoying. They have what they call a phase control, which incidentally the other older one has also, where you can make the two traces come together supposedly and coincide, but they never ever completely match in amplitude, so it's kind of annoying. However, there's a way around that. When these units were developed, and are we going to be able to see the, there we go, I'll stand in front of the lights. Actually, if I turn off some of these lights behind me, that's probably better. When that unit over here was developed, scopes were not very sophisticated, and we talked about that briefly in the last video. They didn't have things like external triggering on them, and a lot of times they didn't even have calibrated vertical and horizontal knobs. It was just two potentiometers, one to change the vertical amplitude and one to change the sweep rate. I'm sorry, there's sweep rate. This is a dual channel scope. A lot of those early scopes were single channel. They only had one channel. You'd only had one vertical pot and one horizontal sweep pot. But as scopes became more sophisticated, you started getting features like external triggering. So I am using the external triggering and only triggering on one direction. Now if we zoom in a little bit, I hope this stays in focus, you can see there's a fair amount of distortion on this waveform. And a lot of that is caused, or almost all of that is caused, from the marker signal being injected. I am using presently, because I don't have crystals ground for these two units. Every one of these has to have its own crystal ground. The frequency would be close if I plugged it in here, but it's going to be off by several hundred hertz because the capacitance and then the inductance, there's a switch on this unit. It's going to be a little bit different. So crystals typically have to be ground for the unit that they're going to operate in, so the inductance and capacitance is matched for that circuit. When you're doing things like CB radios and churning out hundreds and hundreds of them, those are under control. You know, the circuit boards and the wiring in there is going to be fairly close so they can mass produce crystals. But units like this, when you're going between different units, you usually have to grind the crystals a little bit differently. At any rate, I'm using this signal generator right here to generate my marker frequency. And what I'm going to do is put us back on the oscilloscope and zoom in a little bit on the scope here. Hope we stay in focus. Now I am going to sweep this oscillator, and there you see the marker come up. So you have to make sure your signal generator is very accurately tuned, and that won't stay there long. I'll move the whole pattern over just like we did on the other unit. And you can see there's a lot more distortion on the sides of the signal here. Now if I turn the level down, we can get a lot of that under control. You can see the distortions going away. So you have to, and it's a lot broader actually injecting it this way. The marker signal is a lot broader than it was on the 410 unit. This will do the job, but it's a lot more fiddly to play with. There's a lot of settings. I had to use my delay on the scope to get the pattern in the middle. I'm triggering from the horizontal output of the oscillator. I'm using, or the sweep generator. I'm using the sweep generator to generate the trigger. I'm using their sweep output, but I'm not using it to sweep in XY mode. I'm using it to trigger the oscilloscope so that I have the timing correct to match what's happening with the oscillator in the unit. And that allows me to set my trace up. But because these are not linear, the sweep coming out of here is not linear, it takes some fiddling to get the trace on the scope. I played around for about 5 minutes until I figured out how to do it. I should also say I misspoke the other night when I said there was a sawtooth pattern coming out of these units, out of these sweep generators. That's wrong. The output for generating the horizontal sweep is nothing more than a sine wave taken off a tap, a low voltage tap on the transformer, the power transformer. So in reality, the sweep is really nonlinear, because if you know what a sine wave looks like, you know it never has any straight portion. It's constantly changing. What's the word I'm looking for? The profile is constantly changing. Voltage versus time. So, yeah, you know, but it does the job. Oh, that's a pretty good looking pattern I see on the viewfinder here. Looks like you're catching every other frame. What else did I want to do while this one was hooked up? Oh, I will probably go ahead. In fact, I can do that very quickly right here. I am going to, oh, there we go. That got rid of the retrace. Something was, oh, look at that. What the heck's going on here? Ah, I know what's going on. The reason you're seeing that other trace is because you should only be seeing the one trace while I'm doing this. That just dawned on me. I only had a single trace earlier. Another one of these cheap cables. It's triggering the scope twice because on this sweep I've got the timing set up so that the trigger is only seeing half of the AC sine wave. That's the upward one. On the downward one it shouldn't be triggering. But this probably has a bad ground, is what I'm going to guess, so it's double triggering on me. Yep. Okay, so anyway, if you play around with it, much to my chagrin, if you play with this long enough, you can get this kind of a trace by using your external triggering, and you won't have the double sweep. Now I'm going to hook it up the way it was originally intended to operate. Or I should say the way it operated back in the day before you had an external trigger. So I'm going to pull this off. Come on. And move it down here. And I'm going to go into XY mode. Oh, and I just had a delivery truck pull up out front. I'll be back. And this is what you would have had to have dealt with back in the day before your scope had external trigger inputs, and you had to rely on simply this trace sweeping back and forth. Because this unit does not blank the oscillator on the return, you end up with this double trace. Now, in a perfect world, they'd be exactly the same amplitude. I've never seen it happen on these, but they have what's called a phasing control, so that you can bring these two together so you're not seeing this. You can bring the two traces into alignment with one another and get a little better feel, I guess, for what your IF curve looks like. And again, I can sweep my, when I get on 10.7 megahertz, I'm in the center of the IF response. So that is the very earliest version. Okay, moving on. I am now going to connect this unit, and we'll see how it performs compared to the black unit that we're just looking at. We have this one up and running. And again, you see the dual trace. Now here's something that is also an issue with these. You see there's a lot of jitter in the display right now. Watch what happens. Every little vibration in the house, because it's a mechanical, electromechanical resonator, everything, if I just, every little motion sets the thing off. But anyway, this one at least has the blanking feature. Now I'm going to turn on the blanking, which is going to result in a difference in the sweep timing. We'll have to line everything up again. There's the blanking. Now you only have one to deal with. And we can bring that into the center of the screen. Got an awful lot of gain on the scope. But what you'd have to do here is similar to what we did with the other unit. You would have to set your marker frequencies up In this case, I would probably use just a grease pencil on the screen, just like in the old days. Set my 10.625, my 10.775, and my 10.700 center frequency, which is right there. We have a sweep width, but every time you adjust the sweep width, these are pretty fiddly. There we are in the center of the sweep. I can bring my marker up and start introducing some distortion. You can see our markers in the center, more or less. And bring it down. Now I've got rid of most of the bad cabling. That's why the displays are, the sweep is so much cleaner. I spent a few minutes looking for better cables. I went downstairs and actually stole some out of the lab. So there you have it. There's the newer version of the old version. Hi, if that makes sense. Yeah, come on, zoom out, zoom out, zoom out. There we go. So that's this version of the E400 versus the older version of the E400. They'll both work. If you can only find the older one, that's what you'll have to go with, I guess. If you can find the E410, I think you'll find it a whole lot easier to work with. This will do the job. Boy, every time I touch it. The other unit, if I really give it a smack, I can see some change in the tuning, but this one here, that thing is just so sensitive. Every little touch sets it off. Kind of annoying. At any rate, those are your precision apparatus sweep generators. All three of them work, but if you can get a hold of the 410 series, I think you'd be much happier. Again, it's all what you're going to find at the flea market. These are fairly rare. The really old ones, the black colored one, or the black cased one, is very common. Oh, mailman's here. I got another delivery. Busy day, all kinds of stuff coming in. I am steadily losing my voice. I think it's my acid reflux tearing my esophagus up. I may have to go back to sleeping on an inclined bed. I guess that covers it. I can't think of anything I haven't talked about on these. I hope somebody found this information useful and help you make a decision on whether or not you want to buy one of these older units or look around for the E410. In fact, I'm going to take a real quick look on eBay. I took a look on eBay real quick. I cannot even find a listing past or present for an E410, so that kind of goes along with what I said about them being fairly rare. There's not even any history of them being sold. Plenty of these E400s, as well as the E200 series signal generator over here, this guy right here. And while the asking prices, the stupid, ridiculous asking prices, are around $200, $175, the completed ones have been selling for $30 to the highest one I saw was $62, which is far more reasonable. $30 is where you want to be buying one of these, because you're going to spend another $20 to $30 to recap it. You're going to probably put a couple of days into refinishing the enclosure, the steel enclosure, because they're always scratched up and banged up. And it's probably going to cost you $15 for a manual, user's manual, which has the schematic in it. So you'll be into it for, you know, when all is said and done, $75 to $100. It's really too bad I couldn't find any more of the E410 series. That's a pretty nice generator. But again, these do work. The E400s do work. And even if they are a little shaky, when you tap them, they'll do the job if all you want to do is 1 or 2 radios. I'm lucky I found that E410 when I did, and I'm going to hang on to that one. I will probably at some point take these to the flea market and sell these two off, this one and the black one. Taking up a lot of room. And boy, it's getting warm in this room. These things throw a lot of heat, a lot of vacuum tubes in there. So, that's it for now, guys. Hope somebody found some use here. I hope and it answered some questions. I'm going to move on, see if I can find another project, a real project to do. I just wanted to do a quick video of the comparison of these before I put them back up in the barn in the flea market pile. Take care. We'll see you hopefully soon. I'm the Radio Mechanic. Bye-bye.